Okay, class. Well, today we'll look at how to use ANSYS to simulate a frame system. So the basic element will be beam. So the beam have cross area uh, with beam depth, flange width, and web thickness, flange thickness defined here. The material used is a structural steel, and the boundary condition applied is we have fixed on the bottom, and the most bottom beams there are 50 kilonewton per meter line pressure is applied. Okay, we'll go to ANSYS and we'll start to model the structure. So what we'll do is we'll create a static structure system, and because the material is a structural steel, it's a by default material in ANSYS, so we'll move on to next part, geometry. And here for geometry, you can right click property and select line bodies. So then ANSYS will know this is a beam element or frame system. After check this, double click on geometry, which will lead to space claim where we'll create the structure. Okay, now we are in space claim. The first thing we'll do is, as always, make sure the unit is consistent. So the unit we'll use is a meter based on the structure geometry. And the primary precision will increase to 4 in order to define the cross area, because cross area have small numbers. It's a 0.1 millimeter. And then here for the minor grid we'll use 1 meter. And click OK. And then here I will start to choose a surface. We'll select the new sketch plane. We'll choose XY plane surface. And to choose plane view, we'll start to create the structure on 2D surface first. Okay, so when you create lines, I will click a line, I will click lane out sketch. So this is very important. Make sure that you select this. So if you don't select it, when you change to 3D, which is 3D structure, and it will create a surface. And for this problem, we want a line element or beam element, which we want to keep the line structure. So make sure you check layout sketch, and then we start to draw the structure. So we'll start from center. We'll go 6 millimeter, and then 6 meter and 3 meter escape, and we'll start the middle again, and we'll go up by 4 meter, connect the back. So if you can zoom in a little bit. We'll continue drawing, going down line, middle 3 meter, down by 3 meter, 6, 3, 3. Okay, now we have the structure on one surface, and because of symmetrical structure, we will use mirror to generate the other half and then connect the two parts. So to use the mirror function, what we'll do is I'll go to design, I will choose plane tab and click it, which will generate plane here. So you'll see that there's a plane here too. And the next step, I want to go to 3D mode. So, and then we'll mirror. I'll use this plane we created and to mirror the other part to other side. So first thing is I will to use the surface mirror, I will move it to the middle, move this plane to the middle. So in order to do that, I will click move, and then I will choose this plane surface, and then drag it along z direction by 3 meters. Now that's what we have. So we have a surface in the middle, and then we'll go back to the sketch, and then we'll choose the mirror. So when you choose mirrors, first we'll select the mirror, and then you choose what you want. You can choose what you want. Mirror, and then I select all the lines we created. It will be mirrored to other side. And after that, I will remove mirror. Then I will do other operation. Okay, and you also uncheck this plane, and this plane will disappear too. So now once we have these two structures on two sides, and then we need to connect them. So in order to connect them, you have to enable 3D sketch. So that's the key, that you enable 3D sketch, then and ANSYS will know that we'll start to draw lines between the two surfaces. Okay, I will draw lines. 2, 3, 4, 5, 6. All right, so now we have all these lines. And we will use these lines to create beams. To create a beam, we need a cross section area. So we'll go to prepare, profile, and we'll use this shape to generate a beam profile. Expand it, and then add a beam profile. I will input all the numbers into it. So for the width on top flange, we'll use 0.1715. Enter W2, same number. W3, which is the depth of the cross section, it's 0.3556. And then the thickness of the upper flange, which is a 0.0073. Same thing here for the other flange. And the last one is the web thickness here. So here we'll use 0.0115. Alright, and then we can move around to check that all the number right. So it looks good, and then we'll close this section area. And then go back to the structure, and what I do is I will select all the curves that we have created, and still under prepare tab, and it will create. Right, so then we'll have all the beams here. Right, and then I will move all the beams again. So escape, then I select mode, I choose all the beam, and then move to a new component. And you can name it, or I will keep using this name, this component. And click on the component. So now all the lines, they are not connected. So I will, on the share topic topology, we'll use merge. Then all the beams have been merged. Okay, so after that, you can take a view, still at the prepare display, and then choose display solid beam, and you will see what the beam look like. And one thing you might notice that the beams here, this beams, this 1, 2, 3, 4, the beams on this side, the 8 beams, their weak side is used. So we want to use a strong side, so they have a greater bending stiffness. So we'll rotate this and by 90 degrees to get their strong bending stiffness side. So I will choose 1, 2, 3. Use a control click. This 8. So make sure that there's 8 beams has clicked it. Click orange. So either you can drag it by 90 degrees, or you can change the number here on the left corner, 90. So after click, you'll see that the strong side has started facing upward. Okay, now we have this structure, and then we can close this, move on to next step. And then go to the model, double click model. Here we are. Okay, here comes the structure. Alright, so can cross section, so click cross section, you'll see that how it look like. And then we check the beams. Okay, that's the beam we have. The material structural steel, and then cross section, and also coordinate system. And the coordinate system will change and size. Let's change a smaller value because we know that the 3 meter. Let's use a smaller number, and then we can mesh it. Right click on mesh, generating mesh. So we'll see the mesh here, and the next step we'll apply boundary condition. So boundary condition we have is we have fixed support as end. So we'll choose 1, 2, 3, 4, 5, 6. Apply and fix the bottom, and then we'll apply force on it, which is a line pressure, and that will be applied to 7 beams on the bottom. So the 7 edges have been selected, and then apply, and we define the magnitude. So we'll use component, and the force is applied on negative y direction, so it's a negative 50k Newton. Then the boundary condition has been successfully applied, and then we'll look at what output we want to have. We want to look at the deformation, and also this is a beam. I will insert the beam tools, In beam tools, by default, it have direct stress, which is actual stress due to compression or tension. And they also minimum combined stress, which is combine the actual stress with the beam bending stress. So in order to just look at the bending stress, you can input a minimum bending and maximum bending there. So after that, we'll solve the problem. So again, I show you here is for the beam system, there's a bending. There are also either compression or stretching along actual direction. So direct stress reflects the actual stress, and bending stress reflects the bending, and then combined is a combination of a direct stress and the bending stress. Now we can look at the deformation, direct stress, and maximum bending, and minimum bending. So if you have learned beam theory, well, you will know that if there's a pure bending on a beam, if you look at the cross section, so there's a neutral line in the middle, and then on the two sides are minimum and maximum. It will change along cross area linearly. Okay, that's all we have for today.